Here is an explanation for the answer to final exam. Question number 12. In Electronics Demystified, 2nd edition, please see page 418. And at the bottom of that page, you will also find figure exam-2, which I have reproduced here. The question asks us about two sine waves, the same frequency, but 180 degrees out of phase. Neither one of them has a DC component. So both of these are pure sine waves, exactly opposite in phase, and therefore the voltages at any instant in time will add together point by point. For example, here the composite wave will have a 0 voltage. Same thing here, same thing here. The positive peak of the composite will coincide with the positive peak of the stronger of the two waves. The negative peak of the composite will coincide with the negative peak of the stronger of the two waves, and that's wave X. So here what's basically happening is wave Y is taking away from wave X. We're going to get a perfect sine wave as the result when we add two perfect sine waves of the same frequency together, if they are exactly inverted or if they're in phase coincidence. And if neither has a DC component, we're going to get another sine wave. So we can rule out choices D and E. It has to be either A, B, or C. So now we're only concerned with the peak-to-peak voltage of the composite. Well, here is where the positive peak of the composite will take place, and it will be about plus 4.9 volts minus, or plus a negative 2.2 volts. Now I'm interpolating a little bit here. I'm guesstimating, and because these values are not clearly labeled on the diagram, we kind of have to guess. But 4.9 minus 2.2 is going to give us plus 2.7 volts peak here. This situation is exactly inverted from that one. Minus 2.7 volts peak here. The peak-to-peak voltage is the excursion between the positive and negative peaks, which would be 2.7 volts that way and 2.7 volts that way. You add them, you get 5.4 volts peak-to-peak, and that is choice A. None of the other choices come anywhere near, so even a little bit of interpolation error can be tolerated here. By a process of elimination, you have to conclude that the only reasonable choice is A.